Good evening, everyone. Yeah, tonight we are going to solve series of problems. Is that clear? We'll solve series of problems tonight. So on the board we have integral 0 to infinity t exponential minus open bracket alpha minus beta close bracket t dt. So let's consider this. Tonight we are going to look at a series of problems. We'll solve both integral and we'll solve both calculus and elementary algebra. Is that clear? Are you following? Yeah. Is that clear? Okay, so let's consider some of the problems. Yeah. Is a right solution. Integral 0 to infinity t exponential minus open bracket minus beta times t. You know, when you come across questions like this, first thing you should remember is here we have two functions. We have t here, we have exponential. So, and this is integral. So, what are you going to do first? You first consider what is called integration by parts. We use by parts, so you now write using by parts demand. By part is integral v minus integral v du. Hope you are following. Is that clear? If you can see what I'm saying, it means whenever you have something, this will be equals to t, then this exponential minus open bracket alpha minus beta close bracket t be equals to the v. Is that clear? Take notes. So our dv now be equals to exponential alpha beta t dt. So, you know, inside the integration by parts, we have ordinary u, we also have ordinary v. We've gotten our ordinary u as t, but we've not gotten our ordinary v, two of us, and the u. So what we need to do here is for us to differentiate this with respect to t and integrate both sides. So when we differentiate this, we are going to have the u all over the t is going to give us what? 1. Then this implies that for us to obtain u, we cross multiply. The u is equals to the t times 1 is the t, right? Then when we integrate the v, we have v, and integrate this, we are going to have, since we are using by parts, we are not going to put plus, amen? So we are going to have minus exponential minus open bracket alpha beta t all over alpha minus beta, right? This is what we are going to have as our ordinary v. Are you following? Do you understand? Okay. So If you understand very well, if you understand it very well, you can understand it better. You can understand it better. It's a good one. Yeah. Yeah. Are you following? Okay. Yeah. So, as I was saying, what we need to do here is nothing but we have to substitute this into this integral. So we are going to have integral 0 to infinity t exponential minus open bracket alpha minus beta t dt now be equals to, what is our ordinary u? Ordinary u is t, then times ordinary v is minus, so minus t exponential minus open bracket alpha minus beta t at, since it has limit, the integral, so at 0 to what? Infinity all over alpha minus beta, then minus the integral, minus the integral 0 to what? Infinity. So what is our ordinary v is minus this, right? We write minus exponential minus alpha minus beta t. Then what is our du? Is the t, two of us. So times t. Okay? So if you can see what I am saying, here we have to subtract the lower limit from the upper limit. But here, if we substitute, because of this t, here, all of this, both the lower and the upper limit will 0, two of us. So all of this will vanish. Okay? I don't know whether you understand what I'm trying to say. Do you understand? Do you understand what I'm trying to say? You understand what I'm trying to say, right? Okay. So now what we need to do here, okay? Let me just substitute, use this up to substitute. If you understand what I'm trying to say, so anywhere we see t, we substitute in infinity. So here will be equals to infinity exponential minus open bracket alpha minus beta times infinity all over alpha minus beta, then minus open bracket, here is minus, so here will be 0 exponential open bracket alpha minus what? Beta times 0 all over alpha minus beta, right? Then this is what I was trying to say. You put the bracket. Then what you have minus integral 0 to infinity exponential minus open bracket alpha minus beta t dt, two of us. So you can now see that this here, all of this is 0 because of this infinity. Then here too, because of this 0, all of this will be 0, two of us. So can you see what I was trying to explain now? Are you following? Do you understand? Okay, so if you understand what I'm trying to say or do here, so this implies that we'll be left with this minus. Two of us. Minus, okay, sorry, here is minus. So we put the minus. So if this one multiply this, here will be plus. So it implies that whole of this is 0. So here we are going to have the integral 0 to infinity exponential minus open bracket alpha times beta t dt. So with this, you don't need a prophet to tell you. We can easily oh, sorry. I want to forget the denominator. Sorry, my alpha minus beta. Yeah. Sorry about that. That is mathematics for you all over because ordinary v is this. So all over alpha minus beta. So this is common. We factor it out. 1 all over alpha minus beta is common. Integral 0 to infinity. Then exponential minus open bracket alpha minus beta t dt. Right? Are you following? Okay, so when we consider it this way, it means we have to integrate this function. So when we integrate this function, we are going to have 1 all over alpha minus beta, two of us. Then open bracket minus exponential minus open bracket alpha minus beta dt. Then all over alpha minus beta at 0 to what? Infinity. Two of us. True of us is true. Are you following? Do you understand? Hope you are following. Okay. So if you are following, it's simple as ABC. So what we need to do here is to substitute. Let's take off this. So let us substitute. Let's substitute this. Let us substitute this. So it means here will now be 1 all over alpha minus beta, open bracket minus exponential minus open bracket alpha minus beta times infinity all over alpha minus what? Beta, right? Then minus, already there is minus sign here, so put small bracket minus exponential minus open bracket alpha minus beta times minus 0, two of us, the lower limit, then all over alpha minus beta. So because of infinity, the whole of this will be 0, two of us. So this is how it will look like. This is how it will look like. This is equals to 1 all over alpha minus beta, open bracket, here will be 0 because minus times 0 is 0, right? That will be 0. Then minus times minus plus, here will be what? 0. So exponential 0 all over alpha minus beta. Two of us. So the whole thing will now be equals to anything raised to power 0 is what? 1 here. But 0 times this is 0. So you can now see that 1 all over alpha minus beta, put back in 0 plus anything raised to power 0 is 1. So 1 all over alpha minus beta. Amen? Are you following? So you don't need a prophet to tell you. So this implies that this is equals to this times this. Excuse me. So we are going to our final answer. It means therefore our integral 0 to what? Infinity exponential minus open bracket alpha minus beta t dt is equals to this times 0, 0. Then this times this, you know that this is going to give you alpha minus beta all in square. So this is how to go about this type of problem. So should in case you have any challenge on this is how you are going to approach this type of problem. Any question? Do you have any question? No question? So let's proceed further. As I mentioned earlier, that I'm going to solve a series of problems here. It's not only on calculus. Is that clear? It is not only on calculus. So, yeah, let's consider one problem again on calculus. Yeah. Okay, can I clean this? Oh. Okay, I think solve the differential equation. Amen. Okay. So this is y prime plus 6y prime plus 8y equals to 0. This is a second order differential equation. It's simple as ABC, true or false? So what you need to do here is let's write solution. Then our y prime plus 6y prime plus 8y is equals to 0. So now I want to solve this differential equation analytically. So for us to be able to solve this differential equation analytically, that will give us a solution to this differential equation, what we need to do is we now say let y be equals to exponential mx. Yeah. So this will give us the solution to this second order differential equation. Amen. So what we need to do is for us to differentiate this function twice and substitute into the differential equation. So it implies that our y prime is differentiate exponential function. We are going to have m exponential mx, and y prime is equals to, if you differentiate this again, you are going to have m squared exponential mx, true or false? So you substitute this here. Anywhere you see y prime in this differential equation, you write m squared exponential this, y prime, you write this, and y, you write this. Amen? Are you following? Okay. So here, instead of y prime, we write m squared exponential mx, true or false? Then what we have here, plus, what is here, 6. Then what we have here, y prime, which is what? M exponential mx. Then what is here? Plus, amen. Then 8 times y. Y is this exponential mx. True or false? Which is equals to 0. Amen. So you don't need a prophet to tell you already you are close to the differential equation. I'm using factorization method now. Hope you are seeing it clearly. So, as I was saying, hope you are seeing it clearly. Yeah. So, as you can see now, here, what we need to do here is m squared plus 4m open bracket plus 2m plus 8 equals 0. What is common here? M. Two of us. We factor it out. M plus 4 plus what is common here? 2, right? Factor it out. 2m plus 4 equals 0. So you can now see that our m plus 4 equals 0 or m plus 2 equals 0. So our m1 is equals to minus 4 or m2 is equals to minus 2. So now the general solution will now be y equals to a exponential mx m1. Okay. Let me write it up here. Let me write it up here. So the general solution will now be y of g now be equals to a exponential m1x plus b exponential m2x. So our y of g is equals to a exponential, what is our m1? m1 is minus 4, so minus 4x plus b. Then m2 is minus 2 exponential minus 2x. So this is how you are going to obtain this type of differential equation. Any questions so far? Any question? No question, right? So we can proceed to solve indices. Is that clear? We can proceed to solve indices. Okay. Yeah. So let us move further to solve indices. Yeah. So I can claim this. Let me claim this. Yeah. Okay. So let's consider some problem. Indices. One of the problems here says simplify 3 raised to the power of minus 2n. Think so? Oh, n, not 2n. N times 9 raised to the power of 2n minus 1 all over 3 raised to the power of 3n minus 1 dot 9 raised to the power of 2 is simple as ABC. Is that clear? So I'm going to break it down for you to understand it better. Amen? So I will break it down for you so that you will know it better. So let's proceed. And so when you come across expressions of this form, because they are expressions, they are not equations. Expression of this form, what you will first consider is go back to your indices. You know, in indices, we have laws of indices, two of us. We have the multiplication law, we also have the division, we have power law and zero law, two of us. So at first, what will first come into your mind, you find the multiplication multiplication law. Because of here, there is dot here, there is dot here. So both the numerator and the denominator consider multiplication law. So what you need to first consider is the base. The base here we have 3, but here we have 9. So we have to reduce this 9 to base 3 so that we can easily apply the law. The same thing on the denominator. Do you understand? You know very well that 9 is the same as 3 times 3, which is equal to 3 raised to the power 2, two of us. So if you agree with me, it means this will now be 3 raised to the power of n dot 3 raised to the power 2. But note that we have raised to the power 2n minus 1. So we put it in bracket like this, 2n minus 1. Please don't write it this way. Don't write this one this way. Please. This and this, they are not the same thing. Take note. Is that clear? Do you understand? Oh, sorry about it. NEPA has taken light. So we are going to suspend the class. We'll suspend the class. NEPA is taking light.